One of the major reasons we want to study the absolute value is that it provides a good first example of something called a family of functions. A family of functions is just a collection of functions that have similar properties. And in particular, it's a collection of functions that we can build by taking some base function and then composing it with one or more linear functions. So as our first example, we'll take the absolute value functions, which are the functions that we get if we compose the absolute value with one or more linear functions. So for example, if we take the absolute value and compose it with these two linear functions, g of x is 2x minus 1, h of x is x plus 4. If we take g of f of h, that's going to be g applied to f applied to h of x. That's going to be g applied to f is the absolute value, applied to h of x, that's x plus 4. So that's going to be 2 times the absolute value x plus 4 minus 1. Or if we go in the other direction, h composed with f composed with g, that's going to be h of f of g of x. So that's going to be h of f is the absolute value. We apply it to g of x, 2x minus 1. And that's h just takes its argument plus 4. So 2x minus 1, the absolute value, plus 4. So an absolute value function contains an absolute value. It's got linear stuff inside. It's got linear stuff outside. If there's anything else going on, it's not one of these. So this is not an absolute value function because 1 over x is not linear. This is not an absolute value function because there's no way by composing a linear function with an absolute value function that we can get an x added on. Similarly, this is not an absolute value function because we also can't get an extra x multiplied in. And then this is not an absolute value function because the square root is not linear. So in an absolute value function, we can have an absolute value, we can have linear stuff inside, we can have linear stuff outside, and that's it.